Okay, so today we're going to talk about radians and degrees, the different ways that we measure angles. So what is 1 degree? So to define it, 1 degree is the central angle measure of a circle formed by an arc 1/360th of a circle. What that means is we basically took the circle, bring that back, and divided it into 360 equal parts. And if you were to measure one angle, here this only goes to 10 degrees, because obviously one angle is very small, this would be 10 degrees. The central angle from the center here, right, if it's from 0 to 10, 10 degrees. So we kind of arbitrarily divided the circle into 360 pieces. Why 360? It's close to the number of days, right, that it takes us to orbit the sun, 365. And also 60 or 360 is a multiple of 60, which has a lot of divisors. By the way, that's also why our units of time are 60 seconds in a minute, 60 minutes per hour. Anyway, 60 has a lot of divisors. So that's why that was chosen. Okay, so obviously 1 degree is a very, very thin angle of measurement. Okay, well, a radian is the central angle measure of a circle formed by an arc that has arc length r, or the radius. So here's a nice animation to help us understand the radius, or radian. So if you take a circle, which is defined by the radius, right, and take the length of the radius and stretch it along the edge of our circle and drew a central angle, that angle measurement is considered to be 1 radian. And in fact, as you see as our visual here, you need a little more than 3 of them to get half a circle. In fact, you need pi radians. So that actually gives us a conversion there. Pi radians is the same as 180 degrees, or half a circle, and 2 pi radians is equal to 360 degrees. So these are a couple of important conversions here. Pi radians is equal to half a circle, 180 degrees. 2 pi radians equals 360 degrees. And these you really just need to have memorized, because we will convert between radians and degrees quite a bit throughout the rest of the chapter. Okay, well, how do I directly convert? If I want my answer to be in degrees, we're going to take our radian measure, which will usually have pi in it, multiply it by 180, and divide by pi. Okay, if we want our answer to be in radians, we multiply by pi, our degree measure, and divide by 180. And so a way of remembering is that the 180 goes on top and pi goes on bottom, or vice versa, which you might notice is the main difference between these, other than the given angle being in radians or degrees. It helps if you're trying to cancel out pi in the top, so if you're given a radian measure with pi, that you need pi in the bottom so that the pi's would cancel and your degree measure should not have pi in it. Okay, so let's do some conversions here. Convert each degree measure to radians, or each radian measure to degrees. Okay, so the easiest way, if I want to convert this to radians, this is the easiest way to do it. Multiply it by pi, divide it by 180, and reduce your fraction. So in fact, you could divide each by 10, right? Kind of lop off those zeros there. And then of course 6 and 18 can also reduce. If you divide by 6, we get pi over 3. Pi thirds radians. Same thing for our next one. Again, 150 degrees. We're going to multiply it by pi and divide by 180. We can once again lop off the zeros by dividing by 10. And then of course 15 and 18 have a common divisor of 3. So 5 pi sixths radians. And yes, angles can be negative. So in this case, negative 400 degrees, and we'll see why when we get into the unit circle next time. But once again, we multiply this by pi, divide by 180. Now again, we can essentially lop off a 0 by dividing top and bottom by 10. And then hopefully we see these are both even numbers, so for sure we can divide by 2. And we get negative 20 pi ninths radians. Okay, so what if we need to convert from radians to degrees? Well, there's 2 ways of doing this. You can either multiply by 180 over pi, and I like to remember that pi goes in the bottom when we're converting here so that those pi's cancel. And this is fine, you'd get 180 over 6, and 180 divided by 6 is 30 degrees. Okay, nothing wrong with that. The other way, though, which I'd say is more helpful, because you'll need to convert a lot of these in your head later, is you can actually replace pi with 180 degrees. Pi radians is 180 degrees. So if we instead replaced pi with 180 and divide by 6, we can go straight to our answer, 30 degrees. So that actually is very helpful to do this one as well. I'm going to do this time, let's replace pi with 180 and divide by 3. Now, in this case, if you're doing it without a calculator, you can actually divide that by 3 first. 180 divided by 3 is 60. And 5 times 60 is 300. This is the same as 300 degrees. So again, knowing this conversion, that I can replace pi with 180, makes this converting a little bit easier. What about negative 13 pi over 180? Well, if I again replace pi with 180 degrees, now 180 does divide by 5. That may not be super easy to do in your head, but 5 goes into 18 3 times with 3 left over, and 5 goes into 30 6 times. So this is negative 13 times 36, okay, which gives you negative 468 degrees. Negative 468 degrees. Okay, so again, if you're converting from radians to degrees, it's easier if your radian measure has pi in it to simply replace pi with 180. And then if you have a nice divisor of 180 in the bottom, make your value smaller before you multiply and make it bigger. In other words, don't do 5 times 180 and then divide by 3. You're going to get a very large number to divide by 3, and that will be actually less obvious. It's actually easier to make your number smaller by doing the division first and then multiply by 5. If you're converting from degrees to radians, slap a pi next to it, divide by 180, and reduce your fraction. Hopefully it's as easy as that. So hopefully now you have some understanding what a radian represents, which again from our picture here is the angle measure where the arc length is the same as the radius of the circle. So this makes more sense because it's more pure. It comes from the circle. It's not an arbitrary number that we chose, like 360, to divide the circle up into. So pure mathematicians prefer radians. Not to say that there's much wrong with degrees. We can still measure things in degrees, but you will see a lot of radians kind of from here on out in math. All right, so now we know what a degree and a radian is and how to convert between them. Let's talk about the main stuff today, which is the unit circle. Okay, we'll talk about reference angles later on. Don't worry about that for today. Okay, what is the unit circle? This is where we're going to get a lot of those values of cosine and sine and even tangent, which we won't really cover, but sine and cosine from. Okay, so the unit circle is a circle that is centered at the origin. So this is like where we would normally graph stuff. But the very center of our graph is at the origin. It's at 0, 0 on our graph. And it has a radius of 1 unit. So the radius, right, as I go up, down, left, or right, or to any point on here, right, the radius would equal 1. Because remember, the radius is the same everywhere. Obviously, I would need to connect that all the way there. Okay, but our radius is 1 unit. Okay, so angles, when we measure angles on this circle, we always start here on the positive x-axis. So on the right-hand side, and angles are measured counterclockwise, meaning the opposite of the clock, counterclockwise. So a 60-degree angle, I would start from here and go 60 degrees, and then we draw on a side that connects to our circle. That would be a 60-degree angle on the unit circle. Okay, it is possible to have negative angles. Negative angles, instead of going counterclockwise, like our normal ones, go clockwise, like with the clock. Okay, we're not going to really encounter many negative angles, but just understand that's all they represent, going the other direction on the unit circle. Okay, but we always start here on the positive x-axis, and where we stop is called the terminal, which just means to end, side, right? So this other side, the dashed line here, is called the terminal side. All right, so that's what the unit circle is. It's centered at the origin, it has a radius of 1, and this is how we measure angles. Okay, you don't necessarily have to write all of this verbatim, but get some important information from there. It is important to note, centered at the origin, radius of 1. Okay, so here is the full unit circle. Do not write this whole thing down. Goodness, not right now. Okay, there's a ton of stuff to fill in here. And in fact, we're not even going to cover tangent this year just to make it a little bit easier. And today, all we're going to focus on is quadrant 1. So this is quadrant 1 on our graph. This would have been quadrant 2, quadrant 3, and quadrant 4. We're just focusing on quadrant 1. Okay, so notice that there are 5 coordinate points, 1, 2, 3, 4, and 5, okay, in this quadrant. Coincidentally, that's as many fingers as you have on your hand, and I will show you a cool hand trick to come up with these 5 coordinates, but that's what we're focusing on for the rest of this. Okay, on this slide, do not write anything down except for what is in the green box. Okay, you'll have plenty of writing for these notes. All you need to do is pay attention to all of these other things. Okay, but the only thing you'll need to write down eventually is what's in this green box and fill in these coordinates. Okay, but where those coordinates come from, that's what we're going to derive. Okay, so I'm going to show you where they come from. Again, you don't need to write down anything here except for maybe the title and what's in the green box. Okay, so where do those 5 points come from? Why are there 5 points? Why are they important on the unit circle? And they come from our special right triangles. So remember the 30, 60, 90 and 45, 45, 90, right? Those are our special right triangles. So let's say, again, remember this is like 0, 0 at the origin, and the radius of my circle, when I go all the way to the edge of the circle, is 1 unit, right? That's our radius right there. Okay, so let's say I have a 30-degree angle. Okay, the cosine of 30 degrees, like when you type that in the calculator, what it's calculating is how far in the x direction we go where this side ends, where that terminal side is on my circle. So the x coordinate, essentially, of this point is the cosine of 30 degrees. I should be using blue to color coordinate there. Okay, the sine value, I guess I don't have orange selected, but we'll use red, close enough. Sine of 30 degrees is essentially the y coordinate. It's the vertical distance, okay, of this 30-degree angle. So here's how we come up with these values. Remember the 30, 60, 90. If the hypotenuse is 1, the shorter leg is half of 1. So if you remember the 30, 60, 90, remember roughly here, this is an absolutely terrible drawing. Okay, so let's say we have a 30, 60, 90. That's 30, and this is 90, and this is 60. This is the worst drawing of all time. But if you know the shortest leg, right, if that was x, the hypotenuse was twice x, and the longer leg was x root 3. Maybe you remember those values. So here, if this is the hypotenuse, it's twice as big as the short leg. So instead of multiplying by 2 to get to the hypotenuse, we divide by 2, and we get 1/2. In other words, the sine, which again, I have failed to color coordinate, the sine of, that says 1/2, the sine of 30-degree angle is 1/2. When you type that in your calculator and it's in degree mode, it will give you back 1/2 or 0.5. Okay, and that's where it comes from. It's the y coordinate of this point on my unit circle. Now to get to the longer leg, we need to take the short leg, 1/2, and multiply it by the square root of 3. So if I color coordinate here with blue, we take 1/2 the short leg, right? That's what we got here, times the square root of 3. And if we do top times top, bottom times bottom, we get square root of 3 over 2. The cosine of 30 degrees is exactly the square root of 3 divided by 2. Okay, so those are some of our first points. So again, I said all we need to fill in is what's in here. Okay, here at 30 degrees, the cosine is root 3 over 2, and the sine value is 1/2. Okay, there's our coordinates for 30 degrees. Let's check out our next one. What about 60 degrees? And in fact, this is really, it's the 30, 60, 90 again. But x and y have essentially flipped, right? Like now, if my hypotenuse is 1, the bottom cosine is the short leg, which is 1/2. And sine, which is now the long leg, via the kind of the same math we just did above, would now be √3/2. So at 60 degrees, the sine or y coordinate is √3/2, and the x value is 1/2. Again, you just need to write down what's in the green box here, these points as we fill them in. We're just kind of showing you where they come from. Okay, but remember we also have a 45, 45, 90 right triangle. So I cannot draw these for the life of me right now. But if we have a 45, 45, 90, if you remember these properties, the two legs were equal, and the hypotenuse was a leg times the square root of 2. Okay. Now, if we knew a leg, we normally multiply by square root of 2 to get to the hypotenuse. But if I start with the hypotenuse and I want to go back to a leg, we need to divide it by the square root of 2. So we need to take the hypotenuse and divide it by square root of 2. Now, we're not supposed to leave radicals in the denominator. Okay. So to get rid of it, we multiply top and bottom by square root of 2, and we get the square root of 2 over the square root of 4, but the square root of 4 simplifies to 2. So that is the sine of 45 degrees. The square root of 2 over 2 gives me the same decimal, sine of 45 degrees. And because, remember, the two legs are equal, cosine down here is the exact same thing. So we can just copy our answer, √2/2. Okay, so we can fill these in, √2/2 and √2/2. It's the same for both of them. Okay, now a couple other coordinates we haven't quite filled in here. Remember, if the radius is 1 and the bottom down here is 0, 0 on my graph, so if I go straight up at a 90-degree angle, okay, my x-coordinate is still 0, because remember we haven't gone left or right, but we have gone up 1 unit. So the cosine, this would be the cosine of 90 degrees is 0, and the sine of 90 degrees is 1. Okay, so just remembering what these x and y coordinates represent. Okay, the first one is the x-coordinate is the cosine of our angle, and the y-coordinate is the sine of our angle. Okay, where theta here is just our angle. All right, so the other one down here, again, if my radius is 1, right? So we go right 1 in the x direction, but we've gone up or down 0. In other words, the cosine of 0 degrees is 1, and the sine of 0 degrees is 0. So that's what you get back from your calculator when you type in those trig functions. Okay, so make sure you have this part copied down. We'll need this to continue. Once you have that, continue the video. Okay, lastly here we're going to talk about how do we come up with those 5 values, because that's kind of a lot to memorize, even in the green box, right? Okay, well, if we can remember what those special angles were from our special right triangles, 0, 30, 45, 60, and 90, luckily there are 5 points, and we got 5 fingers on our hand. So I'm going to teach you a trick called the left hand trick. So essentially, take your left hand with your palm facing towards you, okay, and you want your thumb kind of oriented like it's on the y-axis, and your pinky oriented like it's on the x-axis, right? And remember, this is essentially 0, 0, right? So we're just kind of modeling this quadrant with our hand, okay? So there is a couple things you have to memorize here, which fingers represent which. So your ring finger is 30 degrees, middle finger is 45, index finger, pointer finger is 60, your thumb is 90, and your pinky is 0, okay, for these degrees. So there is kind of a model that we're going to use here, square root of blank over 2. So we use this every time we use the left-hand trick. Square root of blank over 2. We just got to figure out what goes in that blank and then simplify the answer. Okay, and just like we write the coordinate points, like cosine is x and sine is y, we're going to count cosine on the left and sine on the right. Okay, so here's what I mean by that. We'll do an example. Hopefully this will make more sense. Let's say I want to find the sine of 30 degrees. Now, I could go to that quadrant we filled in. Remember, sine is the y coordinate, and we're talking about 30 degrees. Essentially, it's asking me, what is the y coordinate of 30 degrees? What's the sine of 30 degrees? And the answer is 1/2. Okay, but I'm not going to always have a unit circle with me, so how do I come up with that with this trick? So which finger corresponds to 30 degrees? That would be our ring finger. So what we're going to do is we're going to fold that ring finger down. Okay, so my hand should look something like this now. And because I want sine, we count the number of fingers remaining up on the right of that finger. So in other words, we would count this way. So how many fingers are still remaining up? Just one, right? The pinky. So we would put a 1 in the box here, and it would be the square root of 1 over 2. And the square root of 1 is 1. Our answer is 1/2. And again, we can confirm that. There it is. That's the sine, right? The y coordinate at 30 degrees. It's 1/2. We can get that with this hand trick. Okay, what about instead, what if I wanted the cosine of 30 degrees? Well, cosine, instead of counting to the right, cosine, we count the number of fingers up on the left. So again, it's still 30 degrees. We'd still keep that finger down. How many fingers do we have remaining up on the left for cosine? Is 3. So we would write square root of 3 over 2. And this we don't need to simplify. That is my answer. And again, essentially what this was asking us, cosine is the x coordinate. What is the x coordinate at 30 degrees? Square root of 3 over 2. Now, if you wanted to find, say, give you another quick example here, what is the sine of 45 degrees? Okay, so in this case, you would need to fold your middle finger down, and sine we count to the right. So how many fingers would we have up? We'd have these 2 remaining. So it's the square root of 2 over 2. And so again, essentially sine, remember, is the y coordinate. It's really asking me, what's the y coordinate at 45 degrees? 45 degrees, there's my y coordinate. Sine is the y coordinate. It's root 2 over 2. Okay, we can also use these to find 90 and 0 degrees. And we'll show you that and do more examples in class. So just kind of write down this part, our left-hand trick. If you want to write down one example of how to use that, that's great as well. And then we'll go through hopefully lots of examples in class. It's a pretty important lesson, so make sure you're here for the live session.